Hello everyone, I'm Anthony Ballerino. My project was the upgrade of our dual drive cane shredder from a pneumatic control system to an electronic control system. What is a dual drive turbine cane shredder? Well, this is it behind me. It's a large piece of mechanical plant that processes raw sugarcane and basically smashes it up until it's a pulp ready for the juice extraction. Just to give you a short background on this project, years ago when the mill first started crushing cane in the early 70s, this shredder behind me was a single drive shredder. This means that the turbine, which is this part here, there was only one of these, and it drives the shredder, which has a series of hammers, and the hammers smash the cane as it falls down as it's rotating. So the cane throughput years ago was only about 300 tonnes per hour in this sugar mill, and this was sufficient. This single turbine was sufficient for the capacity of the mill. In later years, the cane land capacity grew significantly, and the business decided that they needed additional throughput. To get the additional throughput through the shredder, they decided to put a second turbine drive on the shredder. What this means simply is just there's one shaft with the rotating hammers, which we call the shredder, and there's a steam turbine on each end of the same shaft. Both those turbines help rotate the shaft. They create mechanical work, and the work is transferred to the shaft, which turns the shaft at about 900 revs per minute at the hammers. The turbines are doing about 6,500 revs per minute. So the additional turbine allowed the throughput to increase. So that increased from about 300 tonnes per hour to about 450 tonnes per hour. So this was the additional throughput that the business required. In recent years, there has been a lot of problems with the control, the speed control of these turbines. Now this is a very, very old system. It was still the original system that the turbines have been operating on. And the system is actually pneumatic. So to give you a little bit of a background of how that works is that we have some what we call pneumatic governors. The governors basically regulate the speed of the turbines. So we do that, so we have to monitor speed of the turbine, and as cane hits the shredder hammers, obviously puts load on the turbines and the speed wants to decrease. The governors sense that and try and maintain a constant speed. So as I said, this is a very old system and works off pneumatic air signals. So we have a transmitter that monitors the speed of the turbines, and as this speed moves, an air signal is sent to the pneumatic governors to either increase the speed or decrease the speed. So this system worked okay for many years, but in recent times the pneumatic governors have given us many speed control issues. Now, I don't want to talk too much about the governors because they're quite a complex piece of governors haven't been supported by the manufacturer for many years. You can't buy parts for them, and there's basically nobody to service and repair them. We hold a few spares here on site in the event we have a major breakdown, but we don't have a complete spare that we can use. So in the last 2 crushing seasons, these governors caused us significant issues. So speed regulation was a major issue, which caused the mill lost time, and we think now that this contributed to one of the mechanical gearbox failures. This was in 2018 season. Once the gearbox failed, this was on what we call the master side, master turbine. We had to disconnect that turbine. So we basically went back to a single drive turbine which is where we were 15 years ago. This hurt the business quite a bit financially, and their business reputation, because we had to lower the throughput of the mills, which in turn reduced the amount of cane that each farmer could send to the mill per day. So the farmers were upset. The mill capacity was significantly reduced. This was for most of the season, and our revenue was significantly reduced because of this. So what was decided was this was basically the catalyst to help me solidify a new project and apply for some capital funding so that we could upgrade the pneumatic controllers to an electronic control system, which would provide significantly improved speed regulation. As part of this project, we wanted to also improve the condition monitoring. At present, the condition monitoring is very poor. We don't monitor temperatures, vibration, not much at all. So condition monitoring was very high priority as part of the new project. So we wanted to do lots of temperature monitoring, lots of vibration monitoring, and also monitor our speeds more closely. This project also required the build of a new turbine control panel. So this is quite a large switchboard that is actually quite complex in nature. In addition to this, we wanted to improve the safety of our systems. Safety is one of the most important things that I'm looking for in all of my projects. So safety to personnel first and foremost, and then safety of the machinery. So with that in mind, and when I wrote my scope of works, I specified that I wanted all the interlocks for our new system to be done through a safety controller. We have many safety controllers on site, and I've specified that same type for commonality of spares. So all of these things were specified in the new specification, which was sent out to tender. I sent this out to 3 companies and awarded it to Energy Power Consulting Engineers, who in conjunction with me designed and built the turbine control panel. Budget for this project I calculated at $300,000. This was approved. Within that, I had about a $30,000 contingency. So the scheduling for this project was actually very tight. So I actually started this project towards the end of November in 2018 and started on the initial switchboard design, which you see behind you, just a snippet of it. So we put together the switchboard size and basically the construction of it, sent that away so that the build could start. From there, I designed the electrical circuits for this switchboard so that when the switchboard got back from manufacture, we could start fitting all the wiring out. So the timing was very tight for this project. As a sugar manufacturing plant, we only have about 5 months downtime where we can implement this project, and it has to be online and commissioned within that time, ready for the 2019 cane crushing season. So this was quite difficult just with the short duration of time. So with that said, I had a number of people working on this project. As soon as we could get the board delivered, I had 2 people working on the board. Had another guy doing all my pipe work for me, more electricians installing the wiring and the sensors, and then we had our fitters and boiler makers modifying the high pressure pipe work for me. So everything was it was a huge challenge. It was very rewarding and very stressful at the same time. But we got through it, and In the last, basically the last week, we had a week where our boilers were brought online here, which are thermal combustion boilers, brought up to operating temperature and pressure to provide us high pressure steam. So the two turbines run off high pressure steam, regulated by our new electronic control system. So we had basically a week to commission the system. This was very challenging, as the rest of our factory was also running steam trials, which has a lot of other things, commissioning and testing. So as part of that process, myself, my leading hand, and the consultants which assisted me in the design of our switchboard and the system, came and did the commissioning. So we commissioned each drive, each turbine individually. Then once that was successfully done, we put the system into dual drive mode, which is the mode we'd be operating 99% of the time, and did our further commissioning. Commissioning went absolutely excellent. I couldn't have hoped for a better outcome. There were only minor bugs and fixes that needed to be done along the way. So there was some small wiring errors that we missed on the drawings, on the electrical schematics when we designed them. So we had to fix them during that week. They were pretty minor. We had some errors with, this is the HMI, human machine interface, and behind this panel's quite a large PLC and the controllers. So we had a few small problems with them, with the programming and the way the programming had to control the system. So these are the two controllers. We've got an advanced digital governor for the master and slave, and probably can't see here, but the PLC's sitting on this wall. So all in all, the project went really well. We're coming under budget, about $30,000 under budget, and the outcome was really good. We got the operators involved, where they came down and used the HMI, so the touchscreen, to control the shredder and get a bit of a feel for how everything worked. That went really well. There was a little bit of feedback of things they liked and didn't like, which we rectified along the way. It was pretty cool to be able to sit down and control the shredder remotely, which we've never been able to do before. So you always had to come down here to control the shredder. Now we can do it from one of our remote control stations. So to be able to manipulate such a large piece of plant remotely from a laptop, a control station, was really cool, and impressed a lot of people here that are pretty hard to impress. So yeah, all in all, the project was a good success. We haven't actually put any cane into it yet, so in about another week's time we'll actually bring the factory online and have cane in our yards supplied by the farmers. Once we put that into our shredder, that'll really place a huge load onto it, and I'll come down probably along with the consultant and we'll do some tuning. So we'll tune our speed response loops to make it the most effective it can be under varying loads. So yeah, all in all, big success. Really enjoyed this project. Hugely stressful, just with the sheer amount of work that had to be done and the complexity of it. Not only the electrical systems, but there was a lot of complexities in the mechanical side, which I basically oversaw all of that. I haven't detailed that too much now because I would just be going on for probably too long. But the mechanical side was a huge challenge for me. Just that it's not my area of expertise, but I had to call on a few people to help me with some of that design work. So yeah, huge challenge, really rewarding, and at the end of the day, to see everything operating and going to plan and the operators being happy was the main thing. The increase in safety for our personnel and for the protection of our machinery was just a major improvement, and got has had excellent feedback so far from our engineering manager, our mill manager, and the operators. So all in all, thanks very much everyone for listening to me talk about my upgrade of our dual drive shredder at Mulgrave Mill. Thank you for the opportunity, and thanks very much.